Hello, everyone, and welcome to AWS Heroes in Conversation. Today, we have Ben Whaley with us, and he is going to talk about alternate. So, Ben, welcome. And why don't you go ahead and introduce yourself to our audience? So, they would really like to know a little bit more about you.
Yes, great. Thanks for having me on. I'm Ben Whaley. I have been an AWS community hero since 2014. I've been working on cloud since before time started, I think, around 2008 or 2009. And I'm really excited to share some work that I've been up to for the past couple of months with the audience and with everyone.
Oh, awesome. So, that's a very interesting name, alternate. So, it seems like it resonates something with NAT gateway. So, I hope you have something very interesting for us today. So, what are we talking about today when it comes to alternate?
We are talking indeed about the infamous, notorious NAT gateway.
Okay.
And maybe I will start by just framing out what the problem is for people who aren't that familiar. So the thing is that NAT gateways are very expensive, especially at large data transfer volumes. And when I say large volumes, I mean on the order of 10 terabytes or so, say per month. And NAT gateways charge inbound and outbound, and we'll get into some of the details on how the pricing works. But this at even larger volumes becomes really expensive. 10 terabytes is kind of the entry level where it starts to hurt. And from there, it just gets more and more painful. And so I thought, is there a better way? Can we find a way to do this a little more cost effectively? And that's what this talk is about.
That's interesting. I think the audience will be very well interested in this. So I'm excited to go forward with the solution. So let's see what we have.
Okay, great. Well, I'll start by just naming a couple of references. This will come in useful to anybody that wants to dig in more on what we're talking about today. There's a GitHub repo you can check out for alternat, and then there's lots of AWS documentation about NAT devices. And I encourage you to look at these docs and search Google for even more information.
Okay. Is alternate one of your personal implementations that you have? Is it available publicly to anyone? Can anyone go to that GitHub repo and fork it and download it or do anything? Is it open source?
By the time this video lands, this will be an open source project that anybody can use. And Alter will be MIT licensed. It is being published under my organizations. The company that I work for, Chime Financial, has been graceful enough to allow this to be open source. So it's under their GitHub.
Okay, awesome. Thank you. Perfect.
Okay, well, let's dive into it if that sounds good to you.
Absolutely. I'll have these reference links posted in the description of this video as well. So yes, let's go ahead. I'm excited.
Okay. So I thought it might make sense to spend just a second talking about what a NAT device is in the first place for folks that aren't that familiar. So here we have a pretty standard VPC kind of layout where we have on the right side, we have the internet. And for the internet to make connections into your AWS network, you have some compute instance, usually could be like a load balancer, right? In a public subnet. And then you have private subnets. On the back end side, in these private subnets, we have compute instances, and kind of by definition, a private instance, an instance in a private subnet, could be a Lambda function, could be an EC2 instance, whatever it is, some kind of compute, a node on the network, doesn't have any public address. That's the definition of being private. It has only a private address. And because of that, it actually can't communicate on the internet because these addresses, the 10 dot addresses, 192.168 addresses, these are called private address space. They're defined in an RFC 1918, and they're not routable over the internet. Routers will refuse to forward them. So if you want your instances in private networks to communicate out to the internet, they have to do so through a proxy device, sometimes called a middle box. And usually that's called a NAT machine. It stands for Network Address Translation. So in the center, in the public subnet, we have this instance called a NAT device, and it sits on both networks. It sits on the private network. We can see that with the 10.0.1.100 address, and it sits on the internet with the 203 address. So it is a bridge between the network. And when when a private instance wants to communicate out to the internet, it sends traffic through an instance, through a NAT instance. And this NAT instance maintains a table. The table translates, it receives connections from the private, and it opens new connections to the public, and it shuttles the data back and forth. So that's the purpose of a NAT device, is to connect private instances out to the internet. Did I
Perfect.
explain that clearly?
Yes, absolutely. Yes, that makes a lot of sense.
Okay. So on AWS, there are a few ways to have NAT devices. There are NAT gateways and NAT instances being the primary ways. And then there's kind of a corollary, which we'll spend a second talking about, which is not exactly the same. It's not the same really as a NAT device, but it's kind of worth mentioning in the context here because I want people to be aware of this option. It's called private link. But at the moment, I want to kind of focus on the first two columns, NAT gateways and NAT instances, because this really is a direct comparison. So looking at the top row, we have management. That means like, who's taking care of this thing? Whose responsibility is it to manage? If you may be aware that AWS has this philosophy of customer responsibility and AWS responsibility, the shared responsibility model. NAT gateways are fully managed and AWS maintains responsibility for them. You don't have to start them. You don't have to patch them. You're not responsible for their uptime, which is really nice. It's a major feature. NAT instances are self-managed, on the other hand. So they're EC2 instances that you have to manage like any other EC2 instance. You're responsible for patching it, for its uptime, and for its security, and all of that. So that's a major difference between the two, and it's one of the biggest differences with NAT instances.
Okay, now that's good. So, I mean, besides being fully managed and self-managed and the bandwidth and the hourly cost, are there any performance differences between NAT gateways and NAT instances? Like, would we say that if I use a NAT gateway because it's fully managed, the performance will be much better? The connectivity will be much better? Or in your experience, it's the same thing? It doesn't matter whichever route you go, you're just playing more for NAT gateways because it's fully managed?
The NAT gateway is a truly remarkable network device. It's extremely well engineered.
Okay.
You can see under the bandwidth column here that it says up
100
to
GP,
100
GPPS, yes.
GPPS, yeah, up to 100 gigabit. And the up to is kind of the key phrase there. When you first launch a NAT gateway, it will handle about 5 gigabit. And if you start
Okay.
throwing more traffic through it, it will scale up in response to demand. And it scales up to quite a phenomenal volume. 100 gigabit is remarkable. On the NAT instance side, it really depends what type of instance you're using, because different types of instances have different network capabilities. So I always recommend the C6N series, like the C6GN, and then there are various categories there ranging from medium to, I think, 24 extra large or 16 extra
Sure.
large or something. So you can get from up to 12 gigabit all the way to a dedicated 100 gigabit. So you can actually match the performance of a NAT gateway. But the hourly cost, as you can see here, is a big difference between the two.
Yeah, you'll be paying as per the instance type, depending upon what instance you provision. So if you have some reserved instances, then that's great. But otherwise, if you have instant or on-demand instances, then that becomes difficult. Got it. Okay, that's interesting.
Yeah, you got it. So the hourly cost of the NAT gateway at 4.5 cents per hour is really quite low. That works out to about $32 a month. It's not a major cost. NAT instances, on the other hand, can be more expensive on an hourly basis. If you use, for example, a C6GN 8XL, that's going to cost you a few $100s a month. So it's quite a bit more. But the key thing to look at is the ingress and the egress cost. So when we say ingress and egress, what we mean is egress is outbound traffic, that is traffic leaving your private instances destined for the internet. And ingress cost is traffic from the internet or from some outside network, right? It doesn't have to be from the internet, but usually it is from the internet internally to your private instances. And so note that in the NAT gateway column, both directions are charged at 4.5 cents per gigabyte. On the NAT instance side, Egress. Oh, you know what? I have these backward actually. I'm going to fix that right now because
Okay.
this is like this, and
That's
this
okay.
is like this,
Okay. So
right?
you have egress cost for NAT instances, depending upon the volume, and there's no ingress cost. Okay. But in NAT gateways, you'll be paying both egress and ingress costs. Understood.
Yeah, you got it. And at small volumes, this is maybe not that meaningful. And certainly the managed nature of the NAT gateway makes it
Mhm.
worthwhile. But when you start to get into higher volumes, like I said, 10 terabyte and up, and it's not unusual for organizations to do hundreds of terabytes or even petabytes per month, this can cost into the tens or even hundreds of thousands of dollars. So
Sure.
it becomes very expensive. With NAT instances, you save on ingress, right? There's no ingress cost at all. So depending on your workload, it can make a lot of sense to switch over to
A
NAT
smaller instance.
instances.
Yeah. You can also
Yeah.
probably use a smaller instance, right? If you don't have that much amount of traffic coming in, you can resize your instance or do something like that as well. Okay. Makes sense.
You
But
can
that
use a
would, the
small.
NAT gateway would be a standard cost associated, irrespective of how much traffic you are having to go through. So that's a standard cost coming your way.
And so it's really this. Um, this is what we're leveraging in to
Okay.
save some money is this ingress.
Ingress.
Because
Okay.
imagine that you're sending 5 terabytes out and 5 terabytes in. So with Net Gateway, you're going to be charged 4.5 cents in both directions. And you're also going to be charged this egress. Like these are additive. The Net Gateway incurs this cost and this cost. So it's really a 1-2 punch, whereas the NAT instance doesn't incur this cost at all. It only incurs this
This
cost
cost.
and it has no ingress cost whatsoever. So NAT instances end up being a lot cheaper for these larger traffic volumes.
Understood. Okay. Maybe we should try that out sometime. Maybe have a separate session on how to host NAT instances. But okay, this is great. And
I
then
want to
how are we
spend,
connecting? Sorry, go ahead.
I'm sorry, were you going to, I didn't want
No, I
to,
was saying, how are we
sorry.
going to, we can have a separate session on, maybe just how to launch NAT instances or something like that for our audience. This is purely theoretical. But since we have private link along with that, how does that tie in with NAT gateways and NAT instances?
Yeah, I wanted to mention these because it's not a proper substitute for NAT gateways and NAT instances. You can't just use them instead of those other options, but they're a nice option to connect your network to some other third-party network that offers private link as a service.
Service.
So there
Okay.
are some examples of vendors out there that offer private link. A really good example is Datadog, who offers a private link endpoint. So the idea is it's a managed device like kind of experience. You provision this private link in your VPC and you set up the routes to point at the private link. And like the NAT gateway, it's fully managed. It's 100 gigabit and it's only 1 cent per hour. It's quite
Nice.
cheap and it
Hmm.
never traverses the public internet. But you can't use it for connection to just anywhere. You can only use it connection to connections for vendors that offer it. Like I mentioned Datadog, there are many others that offer it. So whenever this is an option, I really think private link is the right way to go. But like I said, it's not a general purpose kind of device, just something to not forget about, basically.
Okay, sure. That's an option to explore, I guess, if that option is available and feasible in your solution. So makes sense. Okay.
Okay, so now we kind of understand the pricing breakdown. I thought it might be useful to open up the AWS pricing calculator and look at what it would take to transfer a petabyte to and from each one of them. So I don't want to spoil it there. So we can open up the calculator.aws. This is, in case people aren't familiar with it, this is a really nice way to get an estimate on how
Estimate.
much something will cost. So what I'm going to do here is you can search for the service that you're interested in, and I'm going to search for VPC, and you click configure, and we'll just uncheck the VPN connection. We're not interested in that. Interesting. It's kind of, there it goes. The
There you
toggle
go.
was not working for a second. Okay, we're going to start with the NAT gateway. Remember, I said that the NAT gateway incurs the charge of 4.5 cents ingress and egress and the data transfer.
That's
These are
right.
additive. So I'll just type a name here, NAT gateway costs. Okay, so we're gonna say one NAT gateway, and we said 1 petabyte, I believe.
Yes.
And it doesn't allow you to choose petabyte. So we're just gonna say 1,000 terabytes.
Terabytes.
Okay, and now we also have to add in the data transfer. And I said, I think I said 1 petabyte inbound, 1 petabyte
Well,
egress,
both
and
inbound and outbound. Yes, both egress
yes.
and ingress. Yes.
Okay, so actually we need 2,000 here because the NAT gateway it's got ingress and egress, so two
Both.
petabytes, 1 plus 1. Now for data transfer, 1,000 in and 1,000 out to the internet.
Okay.
So we're going to choose internet. Okay. And I'm going to say save. Okay. Look at this. Down here at the bottom might be kind of hard to see. Monthly cost, $147,000. 12-month cost, $1,767,408. This is not cheap. It's very expensive.
Correct. Very expensive.
Okay.
Yes.
Now we're going to add in the NAT gateway. The NAT instance. Now, again, the toggle is not working for me here. I'll just type it NAT instance data transfer. So the NAT instance, if it's connecting to the internet, it's going to incur data transfer cost. Okay, so we said 1 petabyte in, 1 petabyte out. From the internet, 1,000 terabyte. To the internet, 1,000 terabyte. Okay, we're going to save that as well. But we're not done yet because we also need the cost of the EC2 instance. So I'm going to search for EC2. I'll click configure.
And we said we are going to use C6 or one of those, right?
Yeah, exactly. Let's pick by instance name. And we'll say C6GN. And if we're doing 2 petabyte, that's a fair bit of volume. We might have some spiky. I think we want to use a fairly beefy type. Let's say a C6GN. This is the series to use. The N is the key letter here because this is the network optimized type. Okay, so we're using this type. It's not a cheap type. It's costing us $639
per month.
Let's say on demand. It's costing us $1,000 without using reserved instance or anything.
Oh, boy. Okay. In most of the cases, people will be going for reserved instances, but for right now, we can go with on demand.
Yeah, we'll just kind of use the most expensive option. So that's it. We're done with our pricing. If we look at the summary, in order to really add this up, you need to look at this price for the NAT gateway, and then you need to add this and this to get to the NAT instance. You can kind of see if you add this to this, it comes to about $56,000 versus $147,000, right? So it's about a third of the cost. It's much, much cheaper to go with NAT instances in this case. Okay.
Correct. And that's, again, we took the option of C6, what was that? 8x with it being on demand. So if we go back and change that to reserved instances, that would be even more cheaper.
Yeah, you could reduce this cost.
Reduce that $1,000. Okay.
The big factor to watch always is I always like to optimize the cost of the heaviest thing. And that's really the data transfer. For most companies that are looking to optimize their cost, the cost of the instance is kind of immaterial compared to this cost. It's 1/55th as much, but nonetheless, your point is well taken. Should always do your best. If you know you're going to be using it all year long, you might as well buy an RI.
Yes, makes sense. Okay. No, this is just for optimization, right? But yes. Yeah, of course, depends upon what all options we have on the table.
Okay, so let's come back here. So this is something I always encourage people, check out the pricing calculator. It's a nice, handy way to go calculate.
I'll have that also mentioned in the description of the video, the link for our audience to kind of refer back to. Okay, so, yeah, so this is just a similar pricing scenario that we just saw.
Yeah, these are they're supposed to be the same numbers, except actually one of these numbers is wrong because actually it should be this value. That wasn't factoring in the data transfer cost. So okay. Here's the proper value.
That's okay. I mean, that depends on the region and a lot of other things, right? So sometimes the cost gets updated as well. So that's fine. No worries.
I always love when I make mistakes on my slides and I have to correct them in real time. Isn't that funny?
Yeah, when we debug in production. So while recording, that's perfect.
I don't always debug, but when I do, it's in production.
Exactly. So that's a private link cost, which is the cheapest option as we can see over here.
Yeah, because the price here drops to 1 cent per gigabyte, so it's the cheapest. And I thought I'd throw it in here, even though it's only suitable in a subset of use cases.
Okay, yeah, if it's applicable. But in most use cases, as per your experience, Ben, I think NAT instance would be the ideal way to go. It is feasible, it is doable, and then plus you can resize your instance. The cost is not crazy. It's not super cheap, but it's not even super crazy. It's something that is manageable, I would say.
I mean, comparing the two numbers, it's pretty obvious that NAT instance is better on a cost perspective. The challenge, though, with NAT instances is that the fact that you've got to manage them. And this has been a major drawback of NAT instances all along. So, just going back in time a little bit, NAT instances were around a long time before NAT Gateway. You had to use NAT instances. AWS launched the NAT Gateway, and everybody kind of started using it by default because it was a managed solution.
It's
And
easy.
there are some risks running a NAT instance. If the instance breaks for some reason, or if it goes down, then your internet connection is lost. Not only that, but you have to make sure it stays patched and it's secure. So this is really what the project that I worked on, alternat, is tackling, is trying to make this NAT instance an enterprise grade solution that large companies could trust with their important traffic. And so now that's kind of what I want to jump into next is this is what the solution looks like. Like, how can we set up NAT instances so that they're safe and highly available and secure? So does this seem like a good time to get into what the project is?
Absolutely. So now we've understood the problem. We understood the different approaches that we have to kind of have any internet traffic going over NAT instance or gateway or private link. So yeah, this is your suggested implementation. So let's look into it. What all do we have as part of the solution, and what are the core benefits of the solution, right? So that's something that our audience will be interested in. And you already shared the GitHub repo link to this, so they can actually go inside, check it out, probably fork it, and then probably have their own setup done. You've shared the architecture over here, so maybe would you recommend someone setting up something very similar just to test it out in their own personal account or something like that? Is that something that is doable?
Yeah, you could absolutely deploy it for personal use. I have a demo to share in a minute that I've deployed in my own personal account, or kick the tires in a sandbox environment or a non-production environment in your organization to see if it's going to work for you.
Sure.
This is all implemented in the repository that I linked in Terraform. And then there's a Lambda function to go along with it and a bunch of documentation to explain it all. So anybody who wants to can take a look and try it out for themselves. So let's just kind of touch on some of the key highlights within the architecture.
Sure.
So the first point I make is auto-scaling groups containing one self-healing, self-managed NAT instance per availability zone. So that's a lot of words to unpack. In this diagram, just imagine that this is an availability zone. So if you're in US West 2, there are 4 total zones. Let's say you're in all 4 or 3, it really doesn't matter. It's the same thing deployed into all of them. So there's an auto-scaling group in a public subnet. The auto-scaling group contains one instance, and that instance is the NAT instance. And when the NAT instance boots up, it provisions itself. It claims an elastic IP, it configures itself to be a NAT instance, and then it sets up the routing from the private subnet. It sets the route table to point at itself. So it's really kind of a self-managed thing. If the instance dies, it will replace itself. That's kind of a benefit of auto-scaling, right? A new instance will come online and it will bootstrap itself. So that's like the first feature. But the second feature, and I think the thing that really sets this solution apart from like this auto-scaling HA NAT, this is not something that's new, really. People have been doing this for some time. But the new thing here is the standby NAT gateway. So the idea is that in the private subnets, normally, if everything's working correctly, traffic is transiting the NAT instance. But imagine that there's a problem in the NAT instance. Maybe it, for some reason, experiences a connection failure. which is really unlikely, by the way. Normally, this is going to be very healthy, but every so often you want to patch it. You might need to take it down. The standby NAT gateway you can automatically reroute this Lambda function here. In fact, will automatically change the route to point at the NAT gateway. So either during patching or because the instance experienced a failure of some kind, this function back here, this connection tester function, will be constantly pinging the internet, and it will switch over the route to the NAT gateway at a moment's notice with no traffic lost. Well, with a caveat on that, but I'll come back to that caveat.
Okay.
Primarily,
so the failover just happens automatically. I'm sure that if there are some existing sessions, etc., that we can probably, as you said, touch base later on. We'll have to figure out how those sessions get transferred over from the NAT instance to the NAT gateway, right? So, but at least a failover will automatically happen.
Yeah, the key caveat, I guess, I want to point out, just so people understand the limitation of this. Connectivity to the internet is always maintained. If there's a compute instance in a private subnet that needs to make requests to the internet, it will never have no route to the internet in the solution. However, if there is an instance in the private subnet that has a persistent connection through the NAT instance, like maybe a long-running file transfer over SSH or something like that, that connection will be severed. There's no way to avoid this because the NAT table, remember I mentioned how this works. It maintains a NAT translation table. So that's like a table that maps the internal to the external network. And there's connections on both sides. So if the NAT instance fails and we have to switch the route to the NAT gateway, that one leg of that connection is going to be lost. So there's really no way around that. So there might be a certain use cases where the solution isn't appropriate. For example, if you have long-lived file transfers, that was one example.
Or sticky sessions, I guess, as well. If you have sticky sessions, if you go through the very same instance all over again, then yes, you will use your connectivity or the information for the sticky session.
Yeah, I think what's worth pointing out is that connections through NAT are almost always client initiated. Like if you're hosting a service on the internet, you have a load balancer in a public subnet, and it's like the connection flow is from the internet to the load balancer to your instance, back to the load balancer. There's no NAT instance in that scenario. This is really for clients in private subnets reaching out to the internet to some server and then getting a reply. Like if you run a Yum update or something, that's reaching out to a Yum service on the internet, a Yum repo, getting your package and replying. That's going to traverse the NAT instance. So server connections are like when your instance in the private subnet is a server, it's not going to transit the NAT, and it's kind of out of scope. Does that make sense?
Yep, that's fine. Yes.
Okay.
Okay, so we have failover, we have resilience, we have a self-managed and self-healing NAT instance, and then you said automatic updates and patching. So is that part of the whole self-managed experience for alternate?
Yes. So this auto-scaling group, and it's optional, but what we said is a max instance lifetime. So this is a feature of auto-scaling. On a predetermined basis, it can terminate the instance in the auto-scaling group. And when that happens, it fires a hook to an SNS topic. The SNS topic has a subscription. There's a Lambda function. So the Lambda function fires and changes the route table so that it points at the standby NAT gateway. And that way you don't ever have an EC2 instance that lives for a long time. So it's kind of a security feature. Security teams often don't want long-lived instances. They want to have AMIs that have been patched on a regular cadence. And my idea here, and this works well for my particular use case, but I think it will apply to many people. There's really no reason for this NAT instance to live a long time, unless, like I said, you are in a category where you need to have a persistent connection. You might, if you don't have that requirement, you might as well just replace this, because there's never, like I said, a downtime exactly. There's never a period in which your internet connection is lost. So you can just automatically patch. So that's kind of the purpose of this termination hook.
Okay, makes sense.
Okay, the final thing in this architecture I wanted to point out before jumping into a demo is the VPC endpoint you see here. So the purpose of this is that when the connectivity test and the Lambda function when they need to replace the route, like imagine the NAT instance dies and this connectivity tester function needs to switch the route to point at the NAT gateway. The thing is that this connectivity test, it uses the NAT instance for its path to the internet. So if the NAT instance is down, it wouldn't have a path to the internet in order to reach the EC2 API to switch the route. So it's kind of a catch-22. So what we do to work around that is the VPC endpoint. This is kind of like, it's similar to Private Link. It's the same technology behind Private Link. It's a direct gateway to the EC2 API. So if the instance goes down, the connectivity test function still has a route to the EC2 API so that it can switch over to the NAT gateway. And I realize that that is a little confusing, but if you think that through, you'll see why that's necessary.
Yes, no, absolutely. If the instance is not available, then it has to have an alternate mechanism to connect to the NAT gateway, right? So it's using the VPC endpoint to do that. So that makes sense. Okay.
Yeah.
So,
Okay.
So let's say if somebody has to do this on their own as part of a lab or something like that, so you would recommend them to provision and like go to an AWS region, have 2 availability zones, and use the code from the repo that I believe you said it's a Terraform code. Will that actually spit out the high availability NAT instances as part of the auto scaling group, along with the NAT gateway, the 2 subnets and everything? So this entire setup, is it all scripted as part of the overall repo?
Everything is there, except that you need to have a VPC already.
You need to have a VPC already. Okay.
Yeah.
Okay.
It deploys into a VPC. You pass the Terraform as inputs, you provide it the public subnets, the private subnets, the route tables, and then it deploys the NAT gateway, the auto scaling group, the VPC endpoints, the functions. This is just for demonstration purposes here on the bottom. This compute resources. This could be whatever you're running in your private network that is doing outbound stuff. It could be Lambda functions, EC2 instances, EKS worker nodes, glue jobs, all the kinds of things that need to run in private subnets. So this is like your workload, basically.
Okay. And what about the termination hooks as the SNS topic? Is that also all part of the repo that we have? Okay, awesome. Okay.
Yes.
Makes sense. So then somebody should be able to do have the setup up and running in a short time, as long as they have a subscription and AWS VPC provision, probably a default VPC, I guess, but otherwise they can do it in their personal VPCs as well. Okay, so let's see this in action. This will be very, very interesting.
Okay, here we go. So I have a few different tabs open here. Let's just jump through it.
Okay.
The first tab is instances. So you can see there are 3 instances running. So I've deployed this in just 2 availability zones. This is my own personal account. I don't want to incur very high costs on my own personal account, right? So this could be more zones, but I'm starting with just 2. We're in US West 2, and I have 0 and 1. These are the 2 NAT instances. And then the next one here, this is like coming back to the diagram. This is the compute resource in the private subnet. So it's just an EC2 instance in the private subnet that we can use for demonstration purposes.
Okay.
Now, if we look at the auto scaling groups, here are the auto scaling groups that provisioned those 2 instances. So if I go and look, you can see there's 1 instance running, and the same thing for the other one instance running for their auto scaling groups, each with 1 instance running C6GN mediums. And here we see the lifecycle hook that I mentioned before that posts to an SNS topic. And I think maybe there's one more thing worth pointing out under automatic scaling, monitoring. Where is it? Somewhere there's a setting for the max instance lifetime.
So it should be here on this page.
Max instance lifetime we have set to 14 days.
14 days. So that's when you said that these are all short-lived EC2 instances. Okay.
Yeah. So you could set this to not have a max instance lifetime so that it never automatically terminates. But
just so I understand this very clearly, in the diagram, we have one single auto scaling group, which is being shown as a representation. Over here in the demo, you have 2 auto scaling groups.
1 in each availability zone.
Okay. So one in each availability zone. So you have 2 availability zones. Understood. Okay.
Yeah. So you want to have a NAT instance running in each zone. The reason for that, it's not technically required, but you do incur cross-region, cross availability zone charges.
Yes.
So if you have nodes in US West 2B, but your NAT instance is in US West 2A, first it has to cross over to US West 2A, which is a charge, and then it has to go out the NAT instance, which is another charge. So this is a way to avoid that cross-zone charge.
So the recommendation from your end would be to have a NAT instance auto-scaling group in each availability zone that you have.
Yes, for cost savings and for availability reasons, because if one zone is down, you want to have at least only that zone impacted.
Correct. Yeah.
Okay. And now when we will look at the route table. So I have this VPC, and it has a public route table, and it has a route table for each zone.
Mm-hmm.
And if we look at the routes, we can see the route to the internet, 000. They call this the zero network. You can see it's pointing at this target, an ENI, an elastic network interface. This is one way you can tell that it's going through a NAT instance instead of a NAT gateway, because the target looks like an interface. If this is a NAT gateway, it will say NAT and then an ID. Okay, so that's how we can, and the same thing for this other one. And so if we were to look at this ENI 023, and if we come back to our instance in US West 2A, which is here, and we look at the networking,
you see that as an interface.
We see ENI 023. It's pointing at this instance.
Interface. Perfect. Yes.
Okay, so here's what I want to demo. Now we've kind of got the lay of the land. We have our instances. I've shown you the auto scaling group. I've shown you the route table, and it's pointing at the network. So everything's working fine. So this is that node that is kind of our workload, our pretend workload. We have SSM session manager enabled, so we can get a shell on this host. I like to use bash, right? So now we're on this node, and coming back to the diagram, once again, we're here in the private subnet. And if I want, I can start a ping. I'll just show you. You can ping out to the internet, right? So this is going through the NAT gateway. I'm sorry. It's going through the NAT instance.
Yes.
Too many words throwing around. Okay, but I actually want to put this in the background, and I'll show you why that is in a minute.
Okay.
Okay, so I'm going to say, ping google.com, and I'm going to put this in the background. So now I've got this ping to google.com running persistently in the background. And if I watch the file, I can kind of see it running. So this ping is going on. Okay, so now what we're going to demo is we're going to kill this NAT instance. We're going to terminate it. And what we're going to watch, we're going to observe what happens. And I guess I'll talk through what happens. We'll watch it happen. And then, okay. Okay,
let's see. We don't have a NAT gateway in this, right, yet?
We have no NAT gateway. That's right.
Okay. So but we're in US West. 2 NAT instances in each of the availability zones.
And our private node that we started the ping on, that's in US West 2A. So I'm going to kill the NAT instance that's also in US West 2A.
Okay.
And in order to stay just in the window here, make this nice and easy for us, I'm going to use the AWS Cloud Shell, which is a pretty cool feature in case people aren't familiar with it. I'm just going to actually open up a new one. Oops, I wanted to keep the VPC window open at the same time, so I'm going to open that back up. It says it's waiting to run. I might just give that a second. It should happen really quick. I'm not sure why it's taking so long.
So are we planning to now terminate the NAT instance in what, US West 2A?
Yes, in US West 2A.
Okay.
I'm just preparing your terminal.
And
okay, here we go.
If that instance gets terminated, as per our discussion during the architecture, while we were reviewing the architecture, it should fall back on the instance that is there in 2B.
It should start by giving us NAT gateway. It will route us immediately through the NAT gateway, because remember,
it's going to provision the NAT gateway. Okay, let's see.
It might take some time before the new NAT instance comes up. So the NAT gateway it's going to be provisioned all the time on standby, and it's only going to be used hopefully momentarily, because all the time that we have traffic going through that NAT gateway, we're incurring that higher data processing charge. We want to avoid that whenever we can. So this is a way for us to optimize our spend.
Sure.
Okay, so our Cloud Shell came to life,
Okay.
and the Cloud Shell is cool because it gives you a shell in your network on AWS with all your credentials and everything set up.
Mhm.
So there's multiple ways to terminate instances, but what I want to do is I want to show it with the auto scaling method. So you could just run a terminate instance, but it's not the same as if auto scaling terminated it. So this command, auto scaling terminate instance in auto scaling group, it acts as if auto scaling automatically terminated the instance for some reason. And that's kind of what I want to simulate in this case. So I
Okay.
picked the instance ID of the NAT instance in
Mhm.
US West 2A, and I'm gonna initialize this termination. Okay, so immediately the first thing we can go see in the auto scaling group, I'm going to pick on the one in US West 2A. It's this one, instance management. Now look what we see here. We immediately see the instance that we just terminated. It's entered a state called terminating wait, and then another instance has come into pending. So it gives it a little time, a configurable amount of time, 30 seconds in this case, for this to terminate. That's why I wanted to initialize it this way. If we look
Okay.
at the route table, I'm in a hurry here because we've only got a few seconds to look at it. Notice that already the route is switched, right? And
Yes.
if I look here, my ping, it's still going on, right? Look at it. You can see the ICMP sequence number still climbing. So the ping is active. So we switched over from the NAT instance to the NAT gateway, and the ping is happening. Our session to SSM is maintained. We haven't lost any connection yet. If you had a file transfer going to the internet at this time, it would be lost. It would be closed, and the file transfer would end.
Yeah.
But our connection, the point I'm making with this ongoing ping is that connectivity is maintained even if connections are lost. I hope that it makes
That
sense
makes
what I'm
sense. Yes.
okay.
Yeah. I mean, individual pings are separate connection every single time, right? So if there's a sticky connection or something, a persistent connection, as you said, then that would be disrupted, like a file upload or anything else. Yes.
You're exactly right. Yeah. Okay. So now if we refresh, it has entered a new stage. It was at
Mhm.
terminating wait. Now it's terminating proceed. So it's going to finish the termination process for that instance. So if we looked in EC2, we'll see this thing terminated
And a new one is initializing.
and a new one has come up. And so at some point here, okay, has it happened? No, it's not done yet. I can tell because the ping is ongoing. I'll show you what I'm looking at here in a minute. We'll refresh this. The routes still showing the NAT instance. It often it'll spend a few moments in this
It's probably
terminating
not
proceed
refreshed on
phase.
the screen, but it's just trying to eventually figure out a logical point to have these pings transferred over. So, okay, so it'll take a while.
Yeah, it'll take just a few moments and we'll just watch this. Okay, so now we've seen that the old instance has been removed here. The new one shows that it's in service. If I refresh this again,
Mhm.
I can see, am I looking at the right place? I feel like, yeah,
Um,
I just
Maybe you
refresh.
want to look at go back and you just expand that. Yeah, 2A subbrowse. Yeah, you're looking at the right place. Yes. Maybe it's not just refreshed over there.
Let's just try one more time. Takes a
Like sometimes it
moment.
just takes a while to get refreshed.
Oh,
There
here
you
we see
go.
it.
Yeah.
It just takes a minute, and I know
Yeah.
why that is. I'll show you. So now we have it's pointed at the new NAT instance. So we saw two stages. We saw it switch from the original NAT instance to the NAT gateway. Some time elapsed, and then we saw it switch back to the NAT instance. So that's pretty neat. It's all automatic. Now, look at the ping.
So
It
that
stopped.
whole switching, Ben, right, between NAT instance to NAT gateway and back to the NAT instance is completely transparent or seamless uh, to the end user. I mean, in this case, there's no end user, but the, the the whole experience kind of comes across as very seamless. So you wouldn't even know behind the scenes unless you go and look at the logs that this kind of switch happened. And of course, when you get the bill, you'll know that okay, the NAT gateway game came into play for maybe a few seconds or a few milliseconds, and then you are back to your NAT instance.
Yeah, and then of course those connections that might have been lost, and we have a good
Yes.
example of that here actually. So notice that the ICMP sequence number
Mhm.
it stopped growing. And the reason is not because the ping stopped, but it's because our connection to the SSM is lost now. And this is a quirk of how AWS's connection management happens that I actually don't have a full explanation for. It's something that we really can't see. So if we open up, we can actually open up a new shell
Sure.
to our box, and we'll
Mhm.
see that SSM is still running on the box. I should have a shell here any moment. Might just take a minute. The
Yep.
connection, though, it was interrupted for sure. So that's a sign that something happened. Should come back to life here. Connect.
It's still coming up. It's taking a while.
Well, in any case, we'll see that the ping,
It still stopped
I
over
wrote
there.
it to that file where we'll see that the ping continues, but our session was in fact interrupted. But
Okay.
the routing is happening once again through the NAT instances, and connections remained. So that's really the solution in a nutshell. It's meant to be designed to be really seamless and to facilitate various use cases, like people that want to patch automatically can have that max instance lifetime set. People that don't want to patch automatically can disable that. Can be deployed into different regions and different availability zones, and it's all available as open source. And that's really kind of all I had for the demo.
No, this is great. This is awesome. I think this solves quite a few problems. I mean, not particularly from a cost perspective, but for example, your failover, you had an automated failover, is self-managed, right? And as you suggested, you can have a NAT instance per availability zone. It is a foolproof solution in sense like, hey, if the NAT instance goes down, then falls back on NAT gateway till the time another instance comes up, and then you are back in business with NAT instances. So you might incur some cost with NAT gateway, but that's just a minimal cost versus if you are working or just dependent on NAT gateway per se. So this is an awesome, awesome feature. So thank you so much for sharing this. And just another thing, if you go back to that particular architecture slide, I think it's slide number 8 over there, right? So we did not see the termination hook and the SNS topic and all that, but I assume that that's happening behind the scenes.
Yeah, exactly. It'll be hard to catch in action, but we would be able to see it actually in the logs if we wanted to. If we look at the Lambda.
Okay, let's go and look at that.
We go to the auto scaling hook,
Uh-huh.
and we go to, let's see, monitor, view logs. We should see this.
It's just that I want people to understand there's a lot of magic that's happening behind the scenes, right? Apart from the termination of instances and things that was kind of that we showed to them, but there's a lot of other magic that's happening behind the scenes.
Exactly. Yeah, you can see here the Lambda function was invoked, and
Correct.
it saw the auto scaling group termination. It found the route to replace. It says that it was successful, and then it was done. And so that took almost 2 seconds.
Correct. And then, okay, that's the cost of the Lambda function that you'll be incur or build. Okay.
There's the cost as well of the connection tester function. This is running every minute. And I may even increase that so it runs every 10 seconds or something, or maybe it runs in a loop and stays alive. This is the thing that is always checking connection. So what we did was trigger a termination, but imagine that there's other scenarios in which this could happen. Like maybe your EC2 instance got terminated for some reason. The Lambda function here is always trying to ping example.com. If that fails, it will try to ping google.com. If that fails, it will immediately switch the route over to the NAT gateway. So it's kind of a health checker. And this is running every minute, but still that's only a few thousand invocations per month. It's not a very significant cost.
That's what makes it self-healing as well, right? Because it's able to check whether it is available or not. And if not, it's able to make that decision that, okay, it's time to go and look at the NAT gateway and connect it to the NAT gateway. Okay, absolutely.
Yeah, that's right.
Awesome. This was great. Thank you so
Cool.
much. I think this is one of those solutions, that people can use in their day-to-day lives, especially when they're in the production environment. They're trying to work with their clients, trying to reduce the cost. So this is something that can certainly help a lot of people. And is this continuing further ahead? Oh, there it is.
I couldn't resist. I had to make sure that this was going to work.
That it was working. Okay, no, absolutely.
Now look, the ping is still happening in the background.
Correct.
And if we come back, we left off on the previous one.
At
The shell
358.
broke at 358. So let's just take a look at this file. And let's go to the 358 section.
And you'll see, yes, it's continuing from there.
Yeah, you'll see that there was 0 packets dropped. So the connection is never lost. That's like there's no connectivity is never lost. Established connections are lost, but that's key. And honestly, what this says is something quite magical about AWS networking, because they managed to update these routes. Well, it's not just AWS. Like I suppose any proper network engineer would be able to facilitate this, but the replace route and all this stuff that happens, it's totally seamless to the clients. So kudos to the engineering team at AWS who really works all this magic.
Correct. So the key point over here is that connectivity was not lost. But if you have any specific sticky connections or persistent connections or file uploads or anything, that will be lost. So that is something that our audience should understand very clearly. So let's say if you have any of those sticky sessions or connections, then this might not work as seamlessly for you. But if nothing crazy like that is going on and you have just regular sessions going on, then I think you'll be fine, because the connectivity does remain intact at the end of the day.
Yeah. And not to diminish that at all, but I will say that connections over the internet are unreliable almost by design, right? The internet was built to be reliable in the face of failure. So even a connection through a NAT gateway could be interrupted, or a connection on the internet could kill it. Like a TCP connection open to the internet could be killed for any reason. So any high availability, highly resilient system should retry, or it should somehow reopen a connection and be resilient to those kinds of failures. So if you're in a scenario where a connection failure causes your software to be interrupted, and that's catastrophic, you might think about ways that you can fix that. Right?
Yes. I mean, that's a little bit of an architectural issue with the software, the application, or the web service or microservices, right? I mean, typically the intention is to keep it as autonomous as much as possible. But yeah, absolutely. That's more of an architectural issue, both at an infrastructure level and at an application level. So it has to be addressed at both the places.
That's right. Yep.
Absolutely. This was awesome, Ben. Thank you so much. And thanks for joining the conversation today. Maybe one of these days, what we can do for our audience is, since you have the GitHub repo, we can go through the code. Now they know, if they've seen this in action, it would make a lot of sense for them to kind of relate to the code. We can probably give them a walkthrough, or I'll basically, be open to options as well. Anybody who's watching this video, feel free to post your comments, anything else that you would like to see, and we will be more than happy to record a session and share it with you. But we will be back shortly. Thank you for joining us today. And thank you, Ben, for taking time and, sharing your knowledge with us.
All right. Glad to be here. Thanks.
Take care, guys. Bye-bye.